Most people think about stone when they see a rock, but I see a future device. I am highly motivated to create technologies and understandings from atomic scale up to the complex architectures, not just studying it from papers. Now I'm working with Professor Alexander Tikhonov and his team on synthesizing 2D TMD materials. Also, synthesizing was only half of the battle. Characterizing what you actually got is where the real science happens. I learned how to analyze Raman and photoluminescence peaks and use Atomic Force Microscopy to measure the number of layers. Working with theory using COMSOL Multiphysics made me deeply invested in fabrication of biochips. I have experienced myself how frustrating it is to get damaged material, and I know the feeling of satisfaction when the spectrum finally shows perfect peaks. However, knowing how to synthesize 2D materials and calculating their band gaps is just learning existing properties. I want to bring life into these materials. While studying fat fabrication and helping to Alex student to do photolithography in a clean room for device fabrication, I started to think more about beside material quality, how gates, sources and drains design affects the final device. It hit me that knowing the chip design and architecture is crucial to build working device. To make a chip really useful, you need to understand how to design, simulate, route, and test the actual chip. Instead of being a material synthesizer, I want to become a hardware engineer who understands the full life cycle of a semiconductor device, from CVD synthesis to chip layout and verification. Economy is changing. Countries can no longer rely on raw materials without the help of technology. I am not afraid of long lab sessions. I gained strong momentum doing research, and my background in material synthesis, characterization, clean room device fabrication provide me good foundation to fit the MDV bootcamp program. And the camp is perfect next step to turn my semiconductor passion into actual work.